So we have just solved part A, and now we want to take a look at part B. What is the mean value of x? Now we can actually do this in a couple of different ways, even intuitively, in the sense that we found the density of x in A. So to find the expected value of x, well, we can just use the formula based on the density, right? Where we know that the mean of a random variable x, which is continuous, is given by the integral of x multiplied by its density integrated with respect to x if this integral exists. So this is one way we can do it. Now, how would that look then? Well, we note that our stochastic variable x, i.e. the unconditional loss, it is distributed such that it can only take positive values. So first of all, we can integrate from 0 to infinity instead of minus infinity to infinity. And here we have x multiplied by the density, and I just wrote the density down from the earlier exercise here. So it's x multiplied by the sum for I ranging from 1 to 3 of pi, which were the different weights of the storms, multiplied by the density of the conditional loss in each case, which was lambda I multiplied by e to the minus lambda I x, and then dx. Now what we can notice here is we can actually interchange sum and integral sign in all positive integrals and sums. So we can move out the summation. So I have I equals 1 to 3, and inside here I have the integral from 0 to infinity of x multiplied by pi multiplied by the density of an exponential distribution with parameter lambda I. Now this looks very much like the mean value of an exponentially distributed random variable. The only thing that I don't like is the pi. I don't want it inside the integral, but that's no problem because pi is constant, so I can just move pi outside of the integral. So what I have now is the sum from 1 to 3 over 3 integrals, each weighted with the value pi. And notice what I have here. This is the density of an exponentially distributed random variable with parameter lambda I. And when I take that and multiply it by x and integrate it, this whole thing is the mean value of a random variable. Let's just call it y, where the random variable is exponentially distributed with parameter lambda I. And we have a hint in the exercise that tells us what the mean value of an exponentially distributed random variable is, and we can see it right here. So if y is exponentially distributed with parameter lambda, then y has mean 1 over lambda. So this means that this thing here evaluates to the value 1 over lambda I. So this is just equal to the sum from 1 to 3 of pi multiplied by 1 over lambda I. Well, let's just write this up like this here. pi divided by lambda I. So that was the mean value of the total loss. Now, how can we interpret this? So the mean value of the total loss is the expected value of the loss. So how much do we expect the loss to be? Don't know what just happened there. Just a second. Here. Okay. So how much do we expect the loss to be? Well, in the case where the storm has strength 1, so with probability 1, the storm has strength 1, and in that case we would expect the loss to be to have the expected value 1 over lambda 1, right? And in the second case, where the storm has strength 2, we would expect the loss 1 over lambda 2. So it's kind of conditioned on different strengths. The storm will result in different damages. And in the third case, with strength 3, we expect the loss to be 1 over lambda 3, because we know that depending on the different strengths, the loss will be exponentially distributed with different parameters. And this idea is actually what we have illustrated in our calculations, because this is exactly what we have found to be the expected value of the total loss. It's just what possibility will there be that it is expected to be one thing, and what possibility is there that it is expected to be something else, and then we just take the weighted average of all of these. So this is actually very intuitive and not at all that hard. And I really hope that by doing these exercises this way, instead of going into mixture distribution formulas to begin with, it will help you with your understanding of mixture distributions. So in the next video, we will just solve problem C very quickly, and then we will be coming back and talking about mixture distributions and the formalized version of all of this.